All right. So now, last class, we talked about this formula. Okay. How many, if I have so many atoms, how many moles is it? Okay. Today, we're going to do something else, which is how moles is connected to mass. Okay. Now, I calculate 6.02 times 10 to the power 23 carbon atoms. That is equivalent to 1 mole of carbon. Right? Correct? Okay. Until now, it still has no unit. Okay. It still has no unit, no meaning, nothing. All right. Then, okay, what happens is if you look at the periodic table, okay, if we look at the periodic table, how much is carbon? Carbon is 12, right? Carbon is 12. So it still has no meaning. If 1 mole of carbon, okay, 1 mole of carbon, now it has 12 grams. Now it has meaning. It has a mass. Before that, 12 is just the relative mass. Relative mass of carbon is 12. So got unit or not? No unit. It just means carbon is 12 as compared to oxygen is 16. Carbon is 12 as compared to hydrogen is 1. It's just a comparison. There is no real value. But now, because I put something to it, okay? It's like how much is a rupee? For example, a rupee is five. Five what? Just five. No? A rupee's value is five. It has no meaning, right? But if I say a rupee's value is 50 Malaysian cents, now got value or not? Yes. Okay. So before this, relative mass got no meaning. But when I put 1 mole of carbon, suddenly there's a meaning. So 1 mole of carbon is 12 grams. 12 grams is known as the molar mass, the mass of 1 mole. Okay, can? So everything, that means if I have 120 grams of carbon in a container, inside that carbon, there is 10 moles. And if I'm so free to go and count the atoms, it has 6.02 times 10 to the power of 24 carbon atoms. Do you understand now? Okay. Everybody is so free to go and count this many atoms. No. But everybody is so free to go and measure 120 grams. 120 grams now has a value. It has a value we understand. Can you understand? Okay. So what happens is 1 mole is 12 grams. 2 mole is 24 grams. The 0.5 mole is 6 grams, right? So then, if I have 3 grams, how many moles? How to calculate? We take 12, we take 3 divided by 12, you will get 0.25, right? Okay, so this formula is called amount of moles is mass over molar mass. Okay, molar mass is a value given of 1 mole of a substance. Okay, so molar mass has a unit. Molar mass means every one mass is 12 grams per mole. Okay, so the molar mass of carbon, 12 grams per mole. The molar mass of uh, boron, 11 grams per mole. The molar mass of magnesium, 12 grams per mole. Do you understand? Okay, so now let's try and calculate this. Look at your periodic table and find calcium. Calculate. Okay, please write down the formula. They are looking for moles, right? Moles is mass over molar mass. Okay, 8 grams. Must be in the unit of grams. Molar mass is 40. So you get 0.2 mole. Okay, okay. Okay. If it is okay, wait let's reverse back a bit. How to calculate molar mass? Did I teach you that day? Yes, no. Yes, all this we learned already. Okay, so this is how you calculate all the relative mass. So the relative mass and molar mass, the concept is the same. It's just now got unit. Okay, here is nitrogen gas. Everyone knows in the periodic table, nitrogen gas is N. But what happens is it's actually N2. Why? You see, these in the periodic table always have to be in the form of molecule. They don't exist as atom. Oxygen, nitrogen, fluorine, chlorine, bromine, iodine, astatine, and of course, if you have one more below, it's another one. So all of these have to be written as molecules. N2O2, F2Cl2, Br2, I2. Okay, and one more, H2. They don't exist as atom. Okay, so like this. Fluorine, chlorine, bromine, iodine, hydrogen, oxygen, nitrogen. Okay? When they say nitrogen gas, it is no such thing as one atom of N flying in the air. Cannot. The air, 50% nitrogen. Come on. Cannot, don't know. You learn this in science. Are from one already learn lah. Got 100% got. Either from one, from two, or three. 100% you learned this before. Air got 21% oxygen. That's why when something rusts, oxygen will react 78%. See, suddenly you know. Okay, 78% nitrogen in the air, right now. The 78% nitrogen is not N, it's N2. Okay, so mhm, the molar mass is 28. So 7 over 28. Get it? 0.25 mole. Do you understand? Somebody else is atom. Don't go and create your own theory. Somebody else is an atom. When they are an element, only these 7 elements exist as molecules. Okay, copper is just Cu, carbon dioxide is CO2, ammonia is NH3. Okay, can you please do this? Calculate the amount of mass of molar mass. Now, this topic is not difficult. It's just people lazy to remember because it's math. Actually, the problem is when they are weak at math, then this is going to happen. So last time when during COVID, I was teaching my students this topic online. I teach and teach and teach and teach and teach, but you know lah, COVID, how you all have class? You all look at the laptop and play movie and have class, right? So so what happened was I teach the same topic so many times until one day my daughter, that time she was 5 years old. She finished kindergarten, she was in my room lah. So I was asking the students, what is the formula for amount of moles? They're all silence. So I said, how can you all not know? I teach you all so many times. My upstairs neighbor, downstairs neighbor, left and right, all know already. I think my daughter also knows. What is the formula? And then she told me mass over product mass. So you cannot not know, you have to know. Okay, Okay, done? Done? Okay. 3.2 over 64, you get 0.05, right? 2.2 over 44, you get 0.05, right? 5.5 over 17, you get 1.5, right? Okay, let's look at the next thing. Okay, this is the other way around. Okay, so if amount of moles is mass over molar mass, then what is mass? Moles multiply molar mass. Can you try this question? Do you understand what to do? So how much is chlorine in the periodic table? Chlorine is Cl2, all right? Correct? Okay, in the periodic table is 35.5. So it's 35.5 times 2. So how much do you get? 71. And amount of moles is 0.125. Yeah, 8.875 grams. So it's just the same formula. If you can do add maths, I'm pretty sure you can do this. Okay, this is easier than maths. Okay, what about this? What about this? Is this mass over molar mass formula? No, this is particles. So what do? You try and find the moles first. So there's three formulas. So far I've taught you two. Or there are four formulas. So far I've taught you two. The first formula is amount of moles is mass over molar mass. The formula I taught last week is amount of moles is the amount of particles divided by Avogadro's constant. the amount of particles, you divide by Avogadro's constant. Do you know what's Avogadro's constant? 6.02 times 10 to the power of 23. Do you remember? Okay, so if this is 6.02 times 10 to the power of 22 particles, okay? 1 mole is 6.02 times 10 to the power of 23 particles. How many moles is that? 0.1 mole. That's it. Do you know how to press calculator this value? Do you know how to press exponent in your calculator? Yes. Okay. So you press 6.02 exponent 22. Divide 6.02 exponent 23. You will get 0.1. Can? Do you understand? This is not the answer. You should look for mass. So mass of carbon dioxide is 0.1 mole multiply 44 because carbon dioxide is CO2 is 44. Do you understand? So you get 4.4 grams. Okay, do C and D. If you can do C and D, then I know whether you're correct or not. Okay, that. Do you know what the count or not? So, if you don't know water is H2O, we all start crying. Did you manage to get water is 18? Yes. So the mass is 0.3 times 18. How much is that? Huh? 5.4 gram. Get it? Okay, so this one is not moles, it's like particles. So first you change to moles. So you take, first you find the moles. 1.806 times 10 power 24 over 6.03 times 10 power 20, 6.02 times 10 power 23. How many moles you get? 1.3 moles. Okay, 3 moles. So then 3 times 12 equals to 36 grams. Did you get it correct? Okay? Okay, now this is just the other way around. Just the other way around. Just change the mass. Okay. This one they're asking you amount of particles. Amount of particles is this lah. This is the amount of particles. How many 几粒在里面? Okay, how many inside? Moles is like the big bunch. Particles is how many inside. If I can count 6.02, 10 power 23 is one bunch. So moles is how many bunches. Okay, so now they want to ask you how many particles. Can you find how many particles using mass? What must you find first? Mole. Then from mole, find particle. Get it? Okay. Do you get it? Okay, do. There are only two formulas so far. Amount of moles is amount of particles over Avogadro's constant. That means when they give you a lot of particles, you divide in groups. I make it very simple. Okay. There is 3,000 students in Catholic High School. Okay. I want you to divide them into groups. Every group must have 50 students. 50 students is the. How many groups do you get? Yeah, and that one can drop at maths already. So about 60 lah. Correct or not? Okay. So I have so many particles. How many moles do I have? Moles is the groups. The moles, I divide the how many particles. That's why we did this just now. Just now I have so many particles. I don't know how to calculate how heavy it is because I need moles. So I divide them into one group must have this many particles. Oh, now you only got 0.1 group. This is how heavy it is. Multiply the molar mass. Get it? Yes. Okay. So, and it's just the same formula. So it's just particles over Avogadro's constant. Avogadro's constant is the symbol is Na. And then a next formula is amount of moles is mass over molar mass. That's it. Only two formulas so far. Okay. So if I am asking you to find how many particles, I'm asking you to find how many particles. Which one is how many particles here? Okay. So I am giving you how many mass. I given you this one. Can you use this formula to find moles? Yeah. And then take the moles, put here, and then find particles. Yeah. Get it? Now I got gram. Gram is mass, right? Which formula do I use? Mass over molar mass or particles over Avogadro constant? Okay. Use lah. Use already? Yeah, I think that's correct. 3 over 12 equals to 0. Huh? 0.25 mole. Correct? Okay, now this is mole. I'm asking you how many girls. So if this is 0.25, I just take this, multiply Avogadro constant. Get it? So it's just, so this is molar particles equals to 0.25 multiply Avogadro's constant, which gives me 1.5 1.505 times 10 power 23. Correct? Okay. Do you understand now? Simple, right? Right. Okay. Why are you laughing? It's the same formula. Okay, get it or not? Get it out? Okay. This one, how? 4 grams of hydrogen. Amount of moles over molar mass. 2 mole, right? Amount of particles. 2 mole multiplied Avogadro constant. So you get 1.204 times 10 power 24. Do you get it correct? Okay. 10 grams of calcium carbonate. Calcium carbonate is 100. CaCO3. We did it last week. Will you see that? Did you count this? Okay, count this, count this. I gave you last week. CaCO3 is calcium carbonate. Right? Can? So mass over molar mass, you get 0.1 mole. Did you get this? Yes. And then amount of particles is 0.1 multiply 6.02 times 10 to the power 23. You get 6.02 times 10 power 22. Okay?
We're supposed to write 0.1. Like, can I just write 0.1 for the pen number?
Depends if you're doing working on a question that there's marks or you are just doing calculation for an objective question. Because if it's step 1, step 2, step 3, unit got marks. No unit, no marks. If you're just doing calculation, because it is more, I mean, you've learned since primary class, lah, primary school, no unit, no marks. Right or not? It's not something new, right? You all do science, do maths, got you no unit, got marks. 你考这样多次你不会的，你从小学考试考到现在你不会，got marks 吗？
Like, primary school 的方法。
Not even private primary school. Form 1, Form 2, Form 3. No exam one. Or you all just go like in a trance like that. Okay, okay, okay. Now, okay. You understand the concept? Do you understand the concept? Okay, so far only 2 formulas are mass over molar mass, particles over uh Avogadro's constant. Okay, today I'm going to teach you the third formula. You're not going to like it. Okay, so the third formula is for gas. Okay, I want you to draw this for me. Got empty space on your paper? Why don't you draw this for me? Okay, I have 4 balloons that are 4 balloons. Okay, this balloon has 1 mole helium gas. This balloon has 1 mole hydrogen gas. This balloon has 1 mole carbon dioxide gas. And this balloon has 1 mole nitrogen gas. Okay? Got it? Can I understand what I'm saying? Okay. What I want you to do is number 1, draw these balloons. Number 2, please calculate the mass of each balloon. Okay? Calculate for me the mass of each balloon. Okay. Are you done? Are you done? No.
Yeah.
Yeah, yeah, yeah. Okay, this is 4 grams, right? Right? 2 grams, 44 grams. Sorry, 28 grams, right? Okay. They are all different mass, but they are all the same size, meaning 24 decimeter cube. If it's at room temperature, remember the name we were talking about, room temperature pressure. If it's room temperature pressure, it's known as RTP over here, there. RTP. 1 mole of any gas, it's 25. Okay, 1 mole of any gas at room temperature and pressure. So here room temperature is 25 degrees Celsius and pressure of 1 atmosphere occupies 24 decimeter cube. Do you know how much is 24 decimeter cube? 2 liter. 1 decimeter cube is 1 liter. This one is 2 liter. This bottle is 2 liter. So 24 decimeter cube is 12 bottles of this. So 12 bottles is one balloon. Can you imagine how big? So this big balloon, all of them, the balloon the same size. This big balloon of helium is only 4 grams. So very light or very heavy. A balloon that is as big as my body is only 4 grams. Is it very light or very heavy? Light. So it will float or it will sink. Float. That's why helium balloons will float. Helium balloon will float. Hydrogen balloon will float. Carbon dioxide balloon will sink. Nitrogen balloon will sink. Because the air is 78% nitrogen. Get it? These two balloons will sink. That's why when you blow a balloon, the balloon sink. When I was young, I always thought balloon I blow only can fly. I realized after that is the balloons that can fly is helium balloons. Which one can fly higher, helium or hydrogen? Hydrogen. People fill birthday balloons with helium or hydrogen. Helium, because they don't want people to die. Hydrogen is explosive. You know, remember you do hydrogen test, you put the burning split, it will pop. The pop is more explosion. You put a balloon, it will kaboom. Understand? Okay. Yeah, no, water is H2O, it's a different molecule. No, totally different, totally different. Okay, can you understand? So, what mole. Okay, there is another one called standard temperature pressure STP. Is 0 degrees Celsius 1 atmosphere. The balloon will be smaller, 22.4. These two values no need to memorize. They will give you in exam. 1 mole of, we just take at RTP first, our room temperature pressure. 1 mole of any gas is 24 decimeter cube. It doesn't matter, carbon dioxide gas, nitrogen gas, hydrogen gas, whatever gas, it is 24 decimeter cube. So this comes our third formula. Our first formula is amount of moles. What's our first formula? Amount of moles is particles over Avogadro constant. Our second formula is mass over molar mass. That's amount of moles. Now our third formula, amount of moles equals to volume over molar volume. Molar volume is either 24 or 22.4 decimeter cube, depending on the question. Okay? Can Sana? Okay, let's try this. So it's basically 1 mole oxygen, 24 decimeter cube at RTP. So 2 mole oxygen, 12 decimeter cube. So if I have 6 decimeter cube, what's wrong with me? 48 decimeter cube. If I have 6 decimeter cube, then 6 over 24, 0.25 mole. Get it? Okay? Okay. The only clause is the unit must be the same. It must be decimeter cube. So let's look at this. The amount of moles, the amount of moles is volume over molar volume. Okay, can. So volume is 2.4 decimeter cube, decimeter cube. Molar volume, because they give you RTP, RTP is 24 decimeter cube. Okay, so over 24 decimeter cube, you get 0.1. That's it. Can you understand? Okay, must be the same unit. Okay, do it now. Do ABCD now. Quick, quick, quick. This one is like latihan to be like that. Is your questions in maths and everything. It's just 1 point A, 1 point. It's like your textbook questions. It's not exam question. Exam question is later. Not yet, not yet. I give you warm up question only. It's not hard. Okay, so chill, chill. Don't worry, don't worry. This one is I target about a month to do. Okay, so don't worry. All right. So this one, volume over molar volume. How much you get? 0.05. Okay, this one, volume is 240, but you cannot put 24 because it's centimeter cube. Must put same unit. So you must put 24000. Get it? 0.01. Because 1 decimeter cube is 1000 centimeter cube. 24 decimeter cube is 24,000 centimeter cube. Is that right? Can. I lazy to change the top one. I usually change the lower one. It's the same thing. Okay, can? All right, so 120 over 24000. How much you get? So 0.05, right? Am I counting it wrong? One, two. Right, Did I count wrong? Yes. Okay, now, this is, this is STP. STP is standard temperature pressure. You don't need to memorize these values, but they will give on top there 22.4. They're up there. Okay. STP is standard temperature pressure is 22.4 decimeter cube. Okay. Can you do this? Okay, look carefully. Look carefully. After you find the moles, you must find the mass. How many formulas have I given you? 3 only. Which formula got mass? So you find the moles, and from the moles, you find the mass. Okay? If you are done with question 2, you try question 3, but do question 2 first. Don't stress first. Do question 2 first. Okay? Okay. Ready? Okay. All right. So this one, 44.8 amount of moles, volume over molar volume. So then you get 2 mole, right? Okay. But the question is asking you for mass of oxygen. Remember, oxygen is O2, not O. Okay, oxygen is O2. So O2 is 32. So you take 2 multiply 32, you get 64 grams. Do you get it correct? Yeah. Okay. 224 cm of nitrogen gas. The cm cube, the mole is so 22,400. Okay. 1, 2, 3. How many moles? 0.01, right? Okay. And then the mass of nitrogen. Remember, nitrogen is N2. So 0.01 times 28, because nitrogen is 28, so it's 0.28 grams. Correct? Okay, good. Okay, so moles, 1.2 over 22.4. How much you get? 0.5 mole. And then carbon dioxide is CO2. This one is 44, right? So take 0.5 multiply 44. You get 22 grams. Okay? Did you get all correct? Congratulations. All right. Now, 120 centimeter cube of methane gas is measured at RTP. RTP is 24 decimeter cube. The mass of this gas, so 120 over 24000. This is moles. Okay. How much is this? 0.05 mole, right? Okay, but they're asking you mass. So mass of methane, CH4. So CH4 is 12 plus 4 equals to 16, right? So take 0.05, multiply 16, you get 0.8, correct? Scrap. The amount of molecules. Okay. Is molecules the same as particles? Yeah. You take amount of moles, multiply, Avogadro's constant. 20. 3.01 times 10 to the power of 21 molecules. Do you understand now? Get it? Okay. 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 Amount of atoms. So CH4 got how many atoms? 5. One CH4 got 5 atoms. So if I want to know the total amount of atoms, I just take 3.01. 3.01 times 10 to 2021 is the CH4. So you just times 5. So 1.505 times, this one 21, sorry, times 10 to the power of 22 atoms. Ten to the power 20. Why? Isn't it 0.05? 2, there's no point? No. 21.
22 here.
22. Okay. I count wrong. So that means this one is 23. So this one is 22, 22, and this one is 23, correct? Yeah. Okay. Can. All right. This question is a bit high on the thinking skill. Okay. Under the same conditions, 7 grams of gas Y have half the volume of 14 grams of nitrogen gas. Okay. Calculate the relative molecular mass for Y. It's not like algebra like that. Okay. You only need 2 formulas. You only need one formula. Okay. Amount of moles is mass of molar mass. Okay. Can there's only one thing which you can count. You try and do that first. I give you 2 minutes to think where to start. Okay, anybody found an idea? Come on. Okay, I give you a clue. You are given 14 grams of nitrogen gas. Try that first. You don't know, okay, whenever you don't know what to do, you always calculate the amount of moles. So you calculate the amount of moles of nitrogen, mass over molar mass. You get it, 0.5. You do that first. Okay? Okay. Come on. Anybody? Any breakthrough? Any breakthrough? Okay, like this. The same 7 grams of gas Y. That means mass over molar mass. Do you know the molar mass? Don't know. Has half the volume. If the volume is half, if the volume is half, the mass is, the volume is half, the amount of moles is half or same. Huh? Half. Because 1 mole gas, 24 decimeter cube. So half a mole of gas is 12 decimeter cube. Right now. So the question is saying that if it's the same volume will have same moles. But now they say have half the volume. So half the moles. Half the volume is half the moles. Get it? So how much is Y? Mm. Get it? Relative molecular mass got unit? No. So it's actually not difficult calculation. It's not like maths go on and on forever. The concept is that you must know half the volume is half the moles. You get it? Okay, try the last one. Same concept, same concept. Try question 5, same concept. Any answer? Yes.
You,
How you know?
yes,
Me, teacher Noel, all graduate from UM.
as well.
My one is Bachelor of Science.
Drug science.
Yeah. Most of them I graduated with, they don't do what they graduated at. Some do lah, some do research, all that, but most don't. Okay. Depends on depends. Ours is just a Bachelor of Science. You just study science. But those who do engineering or whatever, some do their engineering job lah. Not all lah, but a lot of them do lah. But my one is a different kind of subject. So it's like you don't have to be a microbiologist or a chemist but a lot of them do lah. Okay. If you have 3 times the volume, does it mean 3 times the mole? Yes. So 0.45 mole, correct? And then 3 times the mass. Methane is 16. So 0.45 times 16, you get? Ta-da! Very good. Okay. Go home and try and do question 6. If you can do question 6, then you are graduated. So you know these 3 formulas connected to each other. Okay? Okay?